Okay, starting from rest, a race car moves 110 meters in the first 5 seconds. What is the car's acceleration? Okay, so starting from rest, that's code for our initial velocity is 0. Our time is 5 seconds. Our change in displacement is 110 meters. And we are looking for an acceleration. Because it moves forward, okay, why use delta? For which one? Delta time or delta x? I mean, for the most part. Well, delta x is because it is a change in position. X being position, so it's a change in position. Now, another way to write both of these would just be x final minus x initial. Time final minus time initial. Now, the reason we don't normally write delta t is because almost always this initial time is just 0, so it just comes right off. So our time is just our final time. So it's at 110 seconds, that's 110 seconds. It's not it's the same as if we put 110 minus 0. Like, it's just sort of pointless. But our delta x, that just indicates that the car has traveled 110 meters from wherever. Delta represents the change. You can actually read delta as the word change in. So change in time, change in displacement. Now, why don't we use that for like acceleration? Because in this case, acceleration is constant. So there is no change in this. We're trying to find its one value. Okay, so let's keep chucking along. Okay, so we're looking for our acceleration here, and let's take a look and see if our old equation, the one we just got done using, can help us solve it. Okay, because we know this, we know enough to solve for this, and we know everything else in here. Okay, so that'll help us solve for this right here. Now, let's go ahead and plug in our numbers and see if we are left with only one unknown. So we know 110 meters is our change in position, and our initial velocity is 0. So anything times 0 is 0. That leaves us with 1/2, and we don't know our acceleration yet, so we can leave that as an unknown. But we do know our time, which is 5, and then squared. So let's go ahead and work this out. 5 squared is 25, and then 1/2 of 25 is 12.5. So we have 110 meters equals 12.5 multiplied by our acceleration. Okay, and if we divide both sides by 12.5, we find out that our acceleration is equal to 110 divided by 12.5. Or 8.8 meters per second squared.